Computers have evolved from simple calculating devices to complex, ubiquitous systems, fundamentally reshaping industries and daily life. What began as mechanical gears and vacuum tubes now manifests as silicon chips and artificial intelligence. The pace of innovation in this sector consistently defies predictions. This continuous drive towards miniaturization and increased processing power, with no clear end, reflects a profound shift in human capability. It alters how information is processed and disseminated across the planet, marking a continuous technological revolution. Early computation began with the abacus in ancient Mesopotamia, 2700 to 2300 BC, facilitating basic arithmetic. Centuries later, Charles Babbage in the 19th century conceptualized mechanical computers. His difference engine aimed to compute polynomial functions. The analytical engine proposed punch cards and a central processing unit, laying theoretical groundwork for general-purpose computing. Ada Lovelace, translating Babbage's work, described algorithms for the analytical engine, often considered the first computer program. These foundational concepts transitioned from manual aids to ambitious mechanical designs. The early 20th century progressed to electromechanical calculators. Konrad Zuse Z3, 1941, in Germany is recognized as the first programmable, fully automatic digital computer utilizing telephone relays. In the US, Howard Aiken's Harvard Mark I, 1944, was another large-scale example. The Atanasoff Berry computer, ABC, 1937 to 1942, is credited as the first automatic electronic digital computer using vacuum tubes for binary arithmetic. The Electronic Numerical Integrator and Computer, ENIAC, 1945, fully programmable, weighed 27 tons with over 17,000 vacuum tubes, consuming immense power for ballistics. The invention of the transistor at Bell Labs in 1947 by Bardeen, Brattain, and Shockley was pivotal. Transistors were smaller, more reliable, consumed less power, and generated less heat than vacuum tubes. This breakthrough immediately impacted computer design, enabling the shift from bulky, unreliable first-generation machines to smaller, more efficient second-generation computers. This innovation allowed for greater complexity and marked the beginning of miniaturization in electronics, a trend still defining computing development. The integrated circuit, IC, independently invented by Jack Kilby, 1958, and Robert Noyce, 1959, combined multiple transistors onto a single semiconductor. This innovation drastically reduced size, cost, and improved reliability, enabling mass production of complex electronics. This led directly to the world's first commercial microprocessor, the Intel 4004, released in 1971. Designed by Fagin, Horf, and Mozor, it packed 2,300 transistors, performing central processing unit functions on one chip. The 4004 inaugurated the fourth generation of computers, paving the way for personal computing. The mid-1970s brought the personal computer, PC, to the public. The Altair 8800, 1975, sparked this revolution. Apple, founded by Steve Jobs and Steve Wozniak, followed with user-friendly machines like the Apple II, 1977. This shifted computing from institutional to individual access. IBM entered the market in 1981 with the IBM Personal Computer 5150. Its open architecture, Intel processors, and MS-DOS operating system created an industry standard. The IBM PC success legitimized PCs in corporate environments, accelerating widespread adoption and fostering a vast software ecosystem. Xerox PARC pioneered the graphical user interface, GUI, in the 1970s, featuring windows, icons, menus, and a pointer. These innovations were famously adopted and popularized by Apple with the Macintosh in 1984. The Macintosh OS presented a user-friendly visual environment, making computers accessible to a broader non-technical audience. Users could interact directly with on-screen elements instead of complex command-line prompts. This paradigm shift in user interaction proved critical for mass adoption. Microsoft later introduced Windows, transforming computing from a text-based skill to an intuitive, visual experience. The Advanced Research Projects Agency Network, ARPANET, established in 1969 by the U.S. Department of Defense, formed the Internet's foundation, enabling communication via packet switching. In 1989, Tim Berners-Lee at CERN proposed the World Wide Web, creating interconnected hypertext. The first web browser, World Wide Web, was released in 1990. Concurrently, networking technologies like Ethernet, 1980s, enabled local area networks, while Wi-Fi, late 1990s, freed devices wirelessly. Bluetooth further facilitated short-range device communication. These developments transformed isolated machines into a global, seamlessly interconnected information platform. Laptops became widely available in the late 1980s and 1990s, offering portability through smaller, efficient components. The true mobile revolution began with smartphones. The first iPhone, introduced by Apple in 2007, combined phone capabilities with a powerful operating system and a multi-touch interface. This integration of computing, communication, and connectivity in a pocket-sized device profoundly changed daily life. Mobile computing now dominates internet access and personal interaction. This shift towards ubiquitous, always-on access has redefined expectations for information availability and device functionality. Cloud computing emerged as a significant paradigm shift in the early 21st century. Users access services and resources over the internet, rather than storing data on local devices. Amazon Web Services, AWS, launched in 2006, popularized infrastructure as a service. This model provides scalable, on-demand access to computing power, storage, and databases, reducing individual hardware investment. Businesses and individuals leverage these remote servers for everything from streaming to complex data analysis, transforming enterprise IT and consumer services through decentralization. Artificial intelligence, AI, has moved from theoretical concept to practical application. Early AI research dates to the 1950s, but recent advancements in machine learning, particularly deep learning, have driven its current proliferation. AI systems now perform tasks like natural language processing, image recognition, and complex decision-making. Milestones include IBM's Deep Blue defeating Garry Kasparov in 1997 and Google's AlphaGo beating a Go world champion in 2016. AI's integration into everyday applications signifies a new era of intelligent machines that learn and adapt. Quantum computing represents a radically different approach, leveraging quantum mechanics like superposition and entanglement. Unlike classical bits, quantum bits, qubits, can exist in multiple states simultaneously, performing certain calculations exponentially faster. While early, quantum computing has potential to revolutionize materials science, drug discovery, and cryptography. Companies like IBM and Google are developing experimental quantum processors. The long-term implications remain largely theoretical, but observed progress indicates a potential paradigm shift in computational power and capability. Moore's law, proposed by Intel co-founder Gordon Moore in 1965, states the number of transistors on a microchip doubles approximately every 2 years. This observation has largely held true, driving exponential increases in computing power and miniaturization. While its continued viability is debated due to physical limits, its impact on computer evolution is profound. It has guided semiconductor research and development, influencing every chip generation. This consistent improvement pace, attributed to Moore's law, has become an industry benchmark, facilitating rapid adoption of powerful, affordable devices. Computer evolution is inextricably linked to operating systems, the software managing hardware and resources. Early systems like CPU-M and MS-DOS provided command-line interfaces. Unix, developed at Bell Labs, introduced multitasking and multi-user capabilities, forming the basis for many modern server OS. Graphical user interfaces with Apple's Macintosh OS and Microsoft Windows transformed user interaction, making computers intuitive. Today, mobile OS like iOS and Android dominate, offering vast app ecosystems. These software layers are critical for abstracting hardware complexity from users. Computer evolution also tracks advancements in data storage and memory. Early computers relied on punch cards and magnetic drums. Magnetic core memory, 1950s, offered faster access. Hard disk drives, IBM, 1956, provided the first persistent, large-capacity storage. RAM allows rapid data access for active processes. Later innovations include optical disks, CDs, DVDs, and flash memory, enabling USB drives and solid-state drives, SSDs. Today, cloud storage supplements local solutions. Each leap dramatically increased capacity, decreased cost per bit, and improved access speed. The open-source movement, emphasizing free availability and collaborative development, has been a significant force. Linux, an open-source operating system kernel created by Linus Torvalds in 1991, provides a robust alternative to proprietary systems. This model fostered innovation, allowing developers worldwide to contribute, audit, and improve code. Projects like Apache Web Server and Firefox Browser demonstrated the viability and strength of open-source solutions. Principles of open source now extend beyond software to hardware and data, promoting transparency and community-driven progress. The trajectory of computer evolution points towards continued diversification and specialized architectures. Beyond quantum computing, research areas include neuromorphic computing, mimicking the human brain, and DNA computing, leveraging biochemical reactions. Advances in materials science could lead to new processing substrates. The Internet of Things will expand exponentially. Ethical considerations regarding AI, data privacy, and digital equity become increasingly central. Coming decades anticipate shifts that could redefine intelligence and interaction, extending computation into unforeseen domains and modalities. Computer evolution has fundamentally transformed society, impacting communication, commerce, education, and entertainment. Global connectivity enables instantaneous information exchange. Automation, driven by computational advancements, has reshaped industries and employment. Digital tools empower individual creativity and productivity. While these developments offer vast opportunities, they also present challenges, including cybersecurity threats, digital divides, and privacy concerns. The ubiquitous presence of computing technology continues to redefine human experience, driving both progress and new societal questions.